In figure, the potential difference between points P and Q is, so this is point P and this is point Q. I need to find the potential difference between P and Q. I'll mark P as the potential at this point and Q as the potential at this point, and I'm supposed to find P minus Q. Now I have two loops without a current source. I have a third loop here, but this is a current source, so I know that I cannot take a loop involving a current source. So I have two loops without current source. So I'll take this current as X. I'll take this current as X. So when I consider this particular node, X flows into this node, 2 also flows into this node. So out of this node, X plus 2 must flow out, right? According to Kirchhoff's current law, the total current entering a node must be equal to the total current leaving the node. Two currents are entering the node and one is 2, the other is X. So the total current entering the node is X plus 2 and that current has to leave out of the node. So this is X plus 2. Now that current flows like this. Now here a part of that flows in this direction. I don't know how much that will be. So I take a new variable here and I take it as y plus 2 because for my ease of doing things, if I take it as y, this will be y minus 2. So to avoid writing a loop equation with minus, for my own simplicity, I have chosen this as y plus 2. So y plus 2 flows in this direction. It reaches this node. 2 flows in this direction and the remaining y flows in this direction. Total I have y plus 2. 2 flows through this direction and I mean through this branch, and y flows through the 2 ohm because this is 2 ampere source. So I know that if current source is there in a particular branch, what it means is that the current source, the value of current source will be the value of current that flows through that particular branch. So this is 2. Now I have two loops and I can write two equations and find the value of X and Y so that I can find the potential drop between P and Q. So if I take this particular loop, I know that I am traveling in this direction. So it is 4 into X, 4X plus 6 into X plus 2. This current is X plus 2. So 6 into X plus 2 minus 10. I am entering the minus terminal of a voltage source. So this is minus. So minus 10 is equal to 0. So 4X plus 6X plus 12 minus 10 is equal to 0, or else I get the value of X as minus 0.2 amperes, which means that current flows in this direction and the magnitude is 0.2. I have taken the direction as this. I got a minus sign, which means that current flows in this direction and the magnitude must be 0.2. Now if I write this loop, 2 into y, 2y. Now I am entering the plus terminal of the voltage source, which means that I have to take it as plus 10. Plus, right, plus 10 plus 8 into y plus 2. Y plus 2 is the current through the 8 ohm. So this is y plus 2. So 8y plus 2. 2y plus 8y is 10y. 10 plus 16 is 26. So the value of y is minus 2.6, which means that I have taken the direction of y from left to right, but I got a minus sign, which means that current flows in this direction with a magnitude 2.6. Now what I can infer is Q has got a potential which is higher than this particular node because current flows from Q to this point, which means that Q has got a higher potential than this point. Now this point has got a higher potential than P because current flows from this point to P. So that is the direction of current is from right to left, which means that Q has got the highest potential followed by this and followed by this, which means that P minus Q will be having a negative value, of course, right? So seeing the option itself, I can say I can guess that it must be minus 6. But let us see how we get minus 6. Now I'm going to find P minus Q. I'll take this potential as T. I mean this point, the potential at this particular node as T. Now Q minus T. Q is the potential at this point. T is the potential at this point. So potential drop between these 2 points will be equal to R into I, value of resistance into current, because Ohm's law says that when you multiply the resistor value with the current, you get the potential drop. So Q minus T must be 4 into 2, which is 4 into 0.2, which is 0.8, right? 0.8 volts. Now T minus, right? T minus P will be 2.6 into 2, which is 5.2 volts. Now if I add these two things, I'll be getting Q minus P, right? Q minus P is 6 volts, or rather P minus Q must be minus 6 volts. In figure, value of R is. So I need to find the value of this particular resistance. Now I'll ground this. I'll keep this as ground so that I can find the values of, or rather I can write the values of potential at various points with respect to this particular node, right? With respect to the potential at this particular node. Now this is 10 ampere, which means that the current flowing through this particular branch is 10 ampere. So this is also 10. Now if this is 5, this must also be 5 because 5 flows through this particular branch. Now when I consider this node, 10 and 5 flows out of this node, which means that this current must be 15. 10 plus 5, 15 flows in this direction, reaches the node, it splits into two parts, 10 and 5. So this must be 15. Now current flows from this point to this point, and that current is 15 amperes. I have a 2 ohm resistor here. So the potential drop between these 2 points must be 15 into 2, which is 30. So I can take that since this is 0, this potential must be 30 because potential difference is the difference between potentials. So 30 minus 0 is 30. 30 divided by 2 must give me 15 amperes. So this potential must be 30. Now, since this is grounded and since there is no other component between this ground and this point, I know that the potential at this point must be 100 because this source has got a value of 100, which means that the plus terminal of this voltage source will be higher than the minus terminal. The potential of plus terminal will be higher than that of the minus terminal by a magnitude of 100 volts. So if this is 0, this must be 100. If this is 50, this must be 150, right? This is 20, this must be 120. So since that I have taken this as ground and this is 0, this is 100 and this must be 40. Now since this potential is 30, the potential drop between these 2 points will be 100 minus 30, which is 70. So this current must be 70 divided by 14, which is 5 amperes. Similarly, a current flows from higher potential to lower potential. This is 40, this is 30. So this current must be 10, right? This current must be 10. Now I have a 10 ampere flowing in this direction. Part of that 5 flows here. So this current must be 5, right? Because this is 10, 5 flows. So the remaining 5 must flow through the arrow. That 5 travels like this, reaches here, this is 5. This 5 and this 5 adds together to give me 10, which I already found it. Right. Now this is 5. Now the potential drop between these 2 points will be the potential drop between the resistor, because if this is 100, this is connected by a piece of wire, so this is also 100. If this is 40, this is connected by a piece of wire, no other components are there in between these 2 points. So if this is 40 volts, this must also be 40 volts, which means that the potential drop across the R ohm resistor will be 100 minus 40, which is 60 volts. Now current is 5. So 60 divided by 5, which must be 12. So 12 ohms must be the value of R.